On YouTube, this is the Middle School Math Man. This video is going to be on solving quadratics by factoring. So, the key thing here is by factoring. Okay, we got to remember how to factor in order to do this. Before we get into some problems where we actually have to factor, like something like this, we're just going to run through two problems. These are already factored. So just going to talk about putting it equal to 0 here before we get into some of the problems where we actually have to factor. So after we factor it, like I said, this is in factored form. In order to get our solutions, we're going to set both of these sets of parentheses equal to 0. So when we do that, we have 4x plus 4 equals 0, and then we also have x minus 8 equals 0. So we're going to solve these little equations, and that's going to give us our two solutions. So we have x equals negative 1, and then over here we have x equals 8. So our two solutions to this quadratic, like I said, it was already in factored form, but we're just going to practice setting it equal to 0 first. So the answers would be negative 1 and 8. Moving on to this problem. Now this looks a little bit different. If you remember back when we multiplied polynomials, remember x plus 2 squared, that is x plus 2 times x plus 2. So make sure to kind of separate that out. So we have x plus 2 equals 0. We're going to set both of these equal to 0 to give us our solutions. So when we solve this, as you can see, we are going to get negative 2. And it's the same answer for both of those because when we set them both equal to 0, they are both x plus 2, so obviously that's going to give us the same answer. So because these solutions are the same, that means the equation has one solution, and that solution is negative 2. Alright, let's get into some problems where we actually have to factor. So this is in standard form. You remember a standard form is ax squared plus bx plus c. So with factoring, the kind of key sentence we always talked about was you need two numbers that multiply to c and add to b. If you remember, like this invisible 1 here, that's the a, the middle term is the b, and the last term is the c. So two numbers that multiply to 12 but add to 7. This is just a basic factoring problem. There were a couple different types of factoring we talked about. We're just going to start with the basic factoring problem. So we got our two binomials. So think of all the ways you can multiply to 12. We have 12 times 1, we have 6 times 2, 4 times 3. We have the negative forms of those, but the two numbers that multiply to 12 and add to 7 out of those options are positive 4 and positive 3. So we just factor that. Now this problem looks like this problem was to start. Like I said, that was already in factored form. So now once we have this, just like we were just doing, we're going to set both of these equal to 0 and figure out what our solutions are. So we have x equals negative 4 and x equals negative 3. So those are the solutions to this problem. This one looks a little bit different, right? Try to see what is a little bit different. Hopefully you said that this problem is not in standard form yet. We need to get this 7x over to the left side. I guess it is in standard form on the left side, but we need to have it equal to 0 on the right, so we need to get this 7x over to this side. So before we even start factoring, we need to make sure our problem is in the correct form, it's equal to 0. So that is what we are going to try to factor now. So now it's just a basic factoring problem. Two numbers that multiply to 16 and add to negative 10. So you notice this negative number, that's going to throw a little bit of a wrench into things. We got to think, okay, two numbers that multiply to a positive number but add to a negative number. Alright, so 16, we have 8 times 2, 16 times 1, 4 times 4. So out of those options, some combination is we're going to have 8 and 2. So you got to make sure that when we add them together, though, they equal negative 10. So the only way to do that, negative 8 times negative 2 is positive 16, but when you add those together, you get negative 10. So that is going to be our factored form, and then we just set them both equal to 0. And then it's a little one-step equation to figure out what our solutions are. So my answers would be, ignore my bad curly brackets, 2 and 8. So two problems, these are just basic factoring problems. This one looked a little bit different because the 7x was on the right side of the equal sign. Now we're going to get a little bit more difficult with our factoring. I didn't mention this before because there was no GCF, there was no number in front of the x squared in the a position. But the first thing you should always look for when you're factoring is there a GCF? In this case, there is. The GCF is 3. Alright, so when we pull out the GCF, that number just goes in front of the parentheses. And then we're going to rewrite everything that's inside the parentheses. So when I take a 3, you can think of it as division. So 3x divided by 3 is just x. 9x divided by 3 is 3x. Negative 12 divided by 3 is negative 4. So now we need to factor what is inside of the parentheses. So this is a basic factoring problem inside the parentheses. So we need two numbers that multiply to negative 4 and add to 3. So two numbers that multiply to negative 4 and add to 3. We have a negative number and a positive number. So the only options for 4 are 4 and 1 and 2 and 2. Now it's negative 4. And we have to add to positive 3. So the way we're going to do that is if we have 4 times negative 1, 4 times negative 1 is negative 4, and then when you add together 4 and negative 1, you get positive 3. Alright, so here we have three things. We have the GCF and we have the two factors. So the GCF doesn't really apply to our solutions, right? 3 equals 0. That doesn't really make sense. So we're going to focus more on the parentheses, and just like we've been doing, x equals negative 4, and x equals 1. So our solutions are negative 4 and 1. The last problem we're going to do is the factoring by grouping method we talked about. This is probably the most difficult type of factoring we did. It requires the most steps. So the first thing we should look for is there a GCF? A lot of times when there's a number in the A position, there is a GCF, but in this case there's not. So if you remember, the first step in a problem like this, when we have a number in the A position, is we are going to multiply A times C. So we're going to multiply 2 times negative 5. Alright, so obviously 2 times negative 5 is negative 10. So now we need to find what are two numbers that multiply to negative 10 but add to positive 3. So two numbers that multiply to negative 10 and add to positive 3. So those numbers are going to be two numbers that multiply to negative 10 and add to positive 3. It's going to be some combination of 5 and 2, right? That 5 has to be positive because when you add those together it equals negative 3. So I'm going to go ahead and erase this stuff over here. So what we basically did is we separated that middle term in a way. 5x and minus 2x, if you simplify that, you get 3x, which is what we started with. But we kind of expanded the problem. Now we're going to group the two. So we have 2x squared plus 5x. And then we have negative 2x minus 5. Now, the next step in factoring these types of problems is we're going to pull the GCF out of each set of parentheses. So the GCF here is x. They both have an x, so when we take out an x, we're still left with 2x plus 5. And then over here, remember, we need the parentheses. The parentheses, what's inside of it should be the same. So we should have 2x plus 5 in this set of parentheses also. And the only way to get that is if we factor out a negative 1. So if I factor out a negative 1, then that turns the signs inside this set of parentheses. It's going to make them positive. So now our last step, remember, we're going to take the stuff that's in front of the parentheses. That's going to give us our first binomial. And then what's shared, the 2x plus 5, that's going to be our second. And then taking it one step further to get our answers, all right, we just need to set these both equal to 0. I'm going to move on to the next page so I have room. It was x minus 1 and 2x plus 5. So we get x equals 1. And then this one is going to get a little bit funky. We're going to have, it looks like a fraction here, which is totally fine. So the final answer is negative 5 over 2 and 1.